Welcome back. In this video, I'm doing daily Leetcode problem, and for today, that's 1937 maximum number of points with cost. Okay, we have Leetcode medium today, and it goes like this. You're given an m times n integer matrix points, 0 indexed. Starting with 0 points, you want to maximize the number of points you can get from the matrix. Okay, to gain points, you must pick one cell in each row. Picking the cell at coordinates R and C will add points row column to your score. Okay. However, you will lose points if you pick a cell too far from the cell that you picked in the previous row. For every two adjacent rows, R and R plus 1, where R is less than M, minus 1 is between 0 and m minus 1, and m is what? Oh, where did I lose m times an integer. Okay. Picking cells at coordinates R and C and R plus 1 C will show. Okay, so the difference between columns to the maximum number of points you can achieve. So in this example, we get 3, 5, 3, but we switched one column, switched two columns, so it's 3, 5, 3. That's 11 minus 2, 9. Yeah, and for this example, 5, 3, 4, that's 12, but we switched one cell here, so it's one less. Okay, let's check constraints. So, okay, yeah, let's try to figure out approach. So I'm struggling with DP problems, dynamic programming, and this is one. So what's the idea behind the dynamic programming? It's storing some calculations so that we don't recalculate them all the time. And in this example, we can like achieve it. Let's look at here. So if we had one row, then only maximum out of this row would be a solution. But when we have second row, what do we do? So we know what's the current situation for the above row, and for this row we'll calculate. So the best this one can get before adding its value. We can look it from the left side and from the right side. And if we look it from the left side, then we can use this calculation for the next one. Like, let's imagine this situation. So this one will first have 1 on the left side. So imagine this is like the best this column can on this row can get. And so for this and this, so we'll always initialize the 0th one for the left side, and we also do the same from the right side, and the last one from the right side. So the first one will be always the value from the best value from above, so which is stored in this column. But for this one, we can do following. We can look. So for the left side, we're gonna look. Is value in this column greater than value in this column minus 1, because we know if we switch one row we can get this value, this value here. So that's essentially the idea, and the opposite for the right side. So for this we will just have 3, and we will try for 5 check if 3 minus 1 is greater than 2, and use the bigger one. So in this example, it's a bit unnecessary, but it's all small examples. I'll code it up and then try to explain. I don't know if I explained it good enough. So let's begin. First, we'll define row, which will be points of 0. So copy of it. And so this is our initial setup. Um, you'll see later what I mean when I say that. Need infinity, which is 10 to the power of 20, just to have some big number to initialize our left and right. And so what do we do? For row, it'll be our index of row in range, so length of points, but we are not going to start from the row from the first row, because first row is already stored in a row here. So we start from the next row. So we are here, and we'll initialize the left and right side for the calculation to determine best for this row. So left is equal to so minus infinity, because we are maximizing in this problem. So minus infinity times let's calculate. So length of row is length of row times L row, and right is the same thing. And for the left side, we are gonna put left of 0 is row of 0. You'll see a bit later why. So because for this calculation, we need to look one to the left, what is the best value for it, but row 0 doesn't have column 0 doesn't have one to the left, so it's just its value. That's for the left side, and for the right side it will have like, so it will make sense. Right of we can do like this, length of row minus 1 is equal to same thing row, so L row minus 1. Okay, so this is our initial setup, and now we need to do pass from left to right. So for I in range, we'll start from 1 to length of a row. So what do? We need to update our left, so left of I, oh, and it's equal to max of, so what we have in a row above, which we can get for free, so row of I, or we can get left of I minus 1, left of I minus 1, but reduced by 1. So let's imagine we are somewhere here. So maybe it's hard to, it's a better example. But yeah, we are calculating always, we know if we look from this number to the left, what is the best maximum value we can get entering this position. And we'll also do the same for the right. And then we're going to take the greater one and store it here. So that's essentially the idea, but the examples here are pretty bad. So not easy to show it and visualize it. So for I in range I to 1 to okay, we update this, and that should be enough. And we need to do the same for from oh, let's write it down. So right to the left for in range. Here we are doing so from the length of the row minus 2, because minus 1 is already done, till minus 1, step is minus 1, to the right of I is equal to max of the row of I right of I plus 1 now minus 1. And in the end, so for in range, oh, wait a minute, range. Wait a minute. For I in range L row, we have the row, so row of I is equal to max of left of I, right of I, and we need to add the value at this position, so that's points of, so row, index of row, and I. And yeah, in the end we just return max of row. This should be it. Let's try to run this just to check all's good. Seems okay. Submit, and then I'll make one more pass to the code. If it's good, yeah, it's good. Seems pretty efficient also. So let's get through it one more time. So what are we doing? Let's maybe have some example here. So we have let's do something like this. So let it be, I don't know, right? My keyboard is dead. Just a second. I'll stop the video to get the cable. Okay, I'm back. So let's get some numbers. So we'll have like 3, then we'll have 10, 3, 4, 15, 11, 12, 5, 6, 2, 2, 2, 7. Let's like one more. So 2, 8, 3, 3, 12, 11, 22. This and this. So yeah, I hope it's clear. I want to do it. This is good enough. Okay, so in this example, what do we do? So we initialize our row here as a first one. So our row is this. And we are at the moment here. And now we build our left. Yeah, we don't need this row. Let's go concentrate here. We are building here left and right. That is here. So first we are going to build our left. And how do we do it? So we are not currently interested in these numbers. We are interested what's the best we can get till, so let's say for this column, for this, what can number be added maximum for this? And we'll get it for the left side, that's for the left of it. And considering it also, and for the right, that's from the right of it. So we have this one. First, we initialize each time. For the left, it's 0th element, so we can check left of it. So it will be 3. And we start our loop from 1, and we check if row of I, so if this one is, which is greater, so previous one or this one -1. So in this situation, it will be 10. So it's row of i's is better. But when we come here, we'll have situation that this one is better. So we'll have here row of I will be 3, and left of I -1 will be 9. So we'll have 9 here. So we know that we can, if we can get by 10, 10 in this column, then we know we can get 9 plus this value in this column. So that's the essential idea. I'll like do for the rest. So for the 4, it's the same thing. So 4, but this time it's 8. Here it's 15. Here it's 11. Here it's 12. For the right side, so we'll start with 12. Here is 11 because it's the same. If we reduce 12 by 1, like this. 15 is 15. 8 is 14. Yeah, no space now. Let's imagine like this. Oof. Yeah, okay. I thought I started to try that, but it's okay. Okay, so here for the number 4, it's we don't actually need to do the right. We can calculate like immediately, or can we? We could. We could like not use right, but when we are doing the right pass, we could update our row directly, but I won't do it. It's a bit, or I can try it. I can try it. I'll do it after this. Let's try to make it. So for this row and right side, it's either 4 or 15 -1, so that's 14. It's either so 4 or 15 -1. Thing. So it's either here 3 or 14 -1, so we'll take 13 for this one. Here it's either 10 or this one -1, but with this one, so it's 12. And it's either 3 or this one -1, so it's 11. And So we now update our row. So it's 5 plus whatever is best here. So it's actually 15 plus 5, that's 20, but minus 1, 2, 3, 4. So that's essentially the idea. So it will be 15 plus 5 minus 4, that's 16, but we can just calculate it with max of these two plus the value. So next row will be 11 plus 5, that's 16. It will be 12. 12 is greater than 10, so it will be 18 here, and you get the idea with it. So let's try to optimize this code. So we don't need the right pass, but how are we gonna calculate? So we don't need right. We need it, but not of this. So we are gonna update row 5, and row 5 will be max of row of I will be max of current row of I, or row of I plus 1. So the next one, its value minus 1, and also minus the value we added, so minus this value. So minus this should be like this. So row of I plus row of I plus 1 minus 1 minus points of. Okay, but in this situation, we would need to, it seems, update row 1 before. We will need this and this. Left to right row. Okay, so row of I is max of row of I, or row of I. We also pass this at the end. Max of row of I plus this one, so we just get the one above and we add, or row of I plus 1, so the next one minus this minus 1. Let's put it like this to be more clear. Okay, and we need so last element of row updated after left pass, so row of minus 1 is equal to, so we need this for sure. Minus 1. And so it will be something like this. So it will be row of minus 1 plus this, or left of, it should be, will it be left of 5? Should be left of 5, should be this. Because left of 5 minus 1 is already, yeah, should be left of 5. Just say this. Because for the edge position, it's always for this for we're doing left to right pass. The rightmost position will have the optimal value for it. So left of minus 1 plus pointers IR. Okay, so row of minus 1 is settled here. Row of I is row of I, row of I plus 1. Minus points of R are plus one, minus one. Okay, we don't need this one. This should give us some progress. I think it is good. Let's try. Okay, looks good. Oh, it's not good. Left of minus plus some edge cases. Rho of I is max of rho of I. Change the reality. That's good. That's okay. What's the big examples? So what's the mistake? 5, 10, and 15. 5 minus 2, that's 10. Yeah, should be. Okay, let's try to. This one will be a bit longer. I'll try to figure it out why this example is good. So I have 5, 2, 1, 2. Next is 2, 1, 5, 2, 5, 5, 5, 0. Okay, so row here will be this. This is row, and we are starting here. And we are building left. So left. So left will be, we'll first get left of 0, and that's row of 0, that's 5. So for this, we're either going to use 5 minus 1, or this one, we're going to use 5 minus 1. We're either going to use 4 minus 1, or this one, we're going to use 4 minus 1. And for this is the same. So we have left here, and let's update our row now. So first we are going to update the last element. So row of minus 1 is left of minus 1, so that's 2. So that's the best we can get when we get to this position. So it's 2 plus IR of minus 1. That's 4. Okay. Okay, and now we are taking iron edge. So from this position, minus 1, minus 1, okay. We are taking max of this, this, essentially this, or yeah, this or this minus 1. So let's calculate. So it's, we take this, that's 3. Do we? No, we do not. We don't even use. That's my bad. So yeah, I should use left here. So we are using best of left of 5, or this is new right of 5. Okay, seems like a silly mistake. Let's try to submit it. And yeah, okay. I'm glad this works. Maybe we see what's the, and this one seems pretty efficient. Should be so. For the time complexity, we go to from all the rows. I'm not sure in description it says. So rows is m, and we go 2 times length of one row, so it's O of m times 2 times n, but it's O of m times n because we don't look at the constant, and we just use of n space for the row and for the left. So let's maybe announce that if we can. Yeah, n times m, and should be O of n of m y m. Y m. Maybe they messed up. M is the length of points, so that's the number of rows, but we are not. Don't know why, but should be of n if I'm correct. Okay, yeah. What did I try? What's the difference? Not solutions, but submissions. So okay, it's a bit better. Seems a bit better. Okay, we made it through. It's a bit longer one. I hope it all makes sense, and yeah, thank you for following in this one, and see you in the next one.